Okay, so we're back here at Iscar, and what you can see taking place behind me is the machining of titanium, aerospace grade 64V titanium, and it's an interesting one, a long edge cutter. Some people call them a porcupine cutter, but the long edge cutter, they're going to do a number of strategies. The one I'm looking forward to, they're actually dropping the cutter and they're going to full slot, like you will have all done using this long edge cutter, but they're going to do the similar process in a trochoidal fashion. I'm fairly sure the trochoidal fashion is going to be quicker and kinder on the tool, but it's not something I've seen before, so I'm actually interested to learn more. As I say, this is 64V aerospace grade titanium on the NVX5080 DMG Morin machine. This is a 50mm diameter, and I believe they're taking a 30mm depth of cut, running at 45 meters. Just to repeat, this is aerospace grade 64 titanium. We're looking at a 50mm cutter with an AP of 30 and a width of cut of 50. It's full slotting this aerospace 64 titanium. We're about to see it also doing a trochoidal path. So we're currently seeing a trochoidal milling strategy using a 6.4 titanium aerospace grade titanium. This is a long edge cutter which is unequally helixed, and also they've got an uneven attack angle for the inserts. This X-Quad extended flute porcupine cutter or long edge cutter, it's 40mm diameter, taking a full width of cut, which is obviously 50mm, with an AP of 30mm running at 45 meters in this aerospace grade 64V titanium. The machine's a DMG Morin NVX5080 BT50 taper, and as you can see, through coolant. Interestingly enough, the insert appears to be quite, very little geometry. Typically we'd see an insert with geometry, but this is a TN insert, and it's IC 882 grade of carbide. The next tool being used is a mill shred. So it's a 90-degree lozenge style insert with serrations on the side. So what you've essentially got now is a indexable ripper cutter. And this is obviously great for chip splitting, reduces power consumption, eliminates vibration. And again, this is 6.4 aerospace grade titanium. Now then, the mill shred P290 line. What we see here is you're opening up this slot into an open pocket using a trochoidal method strategy. Again, using the chip splitter technology, which just to talk about again, it reduces the generation of heat because the shorter contact times. Chips are smaller, therefore you can push productivity due to chip thinning, and this is a really good solution for 6.4 titanium. Typically we may see a 90-degree cutter being used here, maybe high feed, maybe solid carbide, but here at Iscar today it's a mill shred, which is a serrated edge lozenge indexable carbide cutter. This mill shred, P90 line, it's a long edge cutter, porcupine style with serrations in place. This reduces the size of the chips, therefore you can push it harder. Typically, people may think of high feed technology to open up this pocket, maybe even trochoidal milling of a solid carbide tool, but here it is, Iscar today. We're trochoidal milling with a lozenge style 90-degree insert, which has serrations to reduce the chips. So for the people watching live on YouTube, I can confirm this is a 6.4V aerospace titanium grade. And no, it's not a fly cutter. It's some people may call it a porcupine cutter, but I think the correct terminology is a long edge cutter. If you imagined an APKT style insert, a lozenge, it's similar to that with, I think it's got about 12 inserts in this 50mm tool. They've got serrated edges to make smaller chips, which reduces heat, shorter contact times. And yeah, just to conclude, this is doing trochoidal milling. So what we're about to see here is a smaller diameter high feed cutter. And this is something you typically see in an aerospace component. This is what we would class as a closed pocket. There's no open sides whatsoever, which makes it slightly more challenging. And we're going to be ramping down in the Z-axis, again using high feed technology from Iscar. They're going to be running at 50 meters a minute with an FZ of 0.8.